Okay, here's a video on combinations and permutations, part 1. So before we begin, let's look at factorials. Let's just review factorials. We talked about them previously. So we know this is 4 factorial, and it means 4 times 3 times 2 times 1. That's 24. If we had 4 factorial times 2, you just do 4 factorial, 4 times 3 times 2 times 1, and it's times it by 2. And you know 4 factorial is 24, so you can just keep going. 24 times 2, and you get 48. So 4 factorial times 5, same thing. We'll do 4 times 3 times 2 times 1, and then we'll do it times 5. 24 times 5, we get 120. But when you see 4 factorial times 5, you see another number increased. You can just say it's 5 factorial. See, before we did 4 factorial times 2, right? We can't say that is 6 factorial. But 4 factorial times 5, well, it's 5 factorial, and we can prove it here, right? 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So 4 factorial times 5 is 5 factorial. Now if we did 4 factorial times 6, we do 4 factorial and times 6. So it's actually you're doing 4 times 3 times 2 times 1 times 6. Let's say, let me erase this first. Let's say you did 4 factorial times 6 times 7. Well, now there's a continuation here. You can do 4 factorial times 6 times 7 will be 7 factorial. Or let's do one more. 4 factorial times 7, though, is not 7 factorial. So there's a difference between this and this. So this would be, this one, the bottom one, would be 7 factorial. But the top one would be just 4 times 3 times 2 times 1 times 7. So that's the factorials. So you need factorials when we're talking about permutations and combinations. So in combinations, it's remember, order does not matter in combinations. So for example, we talked about this. If we're at a burger place, McDonald's, Burger King, wherever, and you order fries, soda, and a cheeseburger, we'll use these letters here, fries, soda, and a cheeseburger. When you order fries, sodas, and a cheeseburger, right, if you change your mind and say, well, no, you know what, I want a cheeseburger, fries, and a soda, it's the same thing. So order does not matter. In this case, it's a combination. Let's look at, let's say you had red, blue, green, and yellow blocks. Now let's say you wanted to make a combination. Well, it's the only combination you can make. If you started with yellow, blue, green, and red, if you started with that first, well, that's your only combination. But since you started with red, that's the only combination. This would mean the same thing. Let's look at one where we're actually taking the word RGBY. Let's say it was the red, the green, the blue, and the yellow blocks, and we want to take 2 at a time. Well, you can take a red and a green. You can take a red and a blue. You can take a red and a yellow. Now with green, you can't take a green and a red because that'll be the same thing as a red and a green. A red and a green is the same as a green and a red. You can't do that with combinations. But you can do a green and a blue and a green and a yellow. So in combinations, you don't want to repeat what you already had. Then here you can do a blue and a yellow, but that's all combinations you can make. Again, if you made a yellow and a blue, it's the same as if you had a blue and a yellow. So in combinations, you can't repeat the pattern. But with permutations, you can. Permutations, order does matter. So let's look at the word wonder. If you're taking 2 at a time, let's say you're just picking 2 letters at a time, how many combinations can you make? Well, you can just fill it right out. So why don't you pause the tape and tell me, how many combinations can you make? We can start with W. Okay, we have W and 0, and O, W and N, W and D, W and E, W and R. Now we can't repeat W and O, so we can't use OW. But we can use ON, and OD, and OE, and OR. And you'll see a pattern here, right? Then we have N, D, and E, and R. And we have D, we have DE, and DR. And we can do one more with E, ER. Right? And that's all we can do. That's all the combinations we can make, because we can't repeat the pattern because order doesn't matter. It's the same thing if you did a 0 or a W. It's the same thing if you did NO. That's why order doesn't matter. Now we can do it this way, or there's a formula we can use. Okay, so we know we have 15 combinations here with the word wonder when we're taking 2 at a time. 2 at a time. So what we can use is this formula here. We can use K. Sometimes they use R. N means the total amount you have. So let's look at this. Write the word wonder here. And the total amount we have 1, 2, 3, 4, 5, 6, right? So the N represents the total amount you have, 6. The K, or the R, sometimes they use R, represents the amount you want to take at a time. We want to take 2 at a time, so there it goes, 2. Okay, so again, here's the formula. We'll talk about this one in a minute. So the N is 6, so we're going to say 6 factorial over 6 minus 2 factorial times 2 factorial. So you see how I plug that in? Okay. So what do we do with 6 factorial? What do we do with 6 minus 2 factorial? What do we do with 2 factorial? Well, you know how to do factorials, and this is division, right? We know fractions are division, so see if you can answer that question. Okay, so let's write it over here. We have 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Right? And we had 6 minus 2, so that's 4 factorial, so that's 4 times 3 times 2 times 1. And then we had 2 factorial, which is 2 times 1. So we can we can cancel out the top numbers and the bottom numbers. If they're the same, we can cancel the 1 here, the 2 here. We can cancel the 3 and the 4. We can also cancel more, but we'll talk about that in a minute. So what we have left up here is we have 6 times 5, which is 30. And then we have 2 times 1, which is 2. That'll give us 15, which we talked about before. So you can use this formula again right here, this formula right here, to get the combinations. Now I said before we could have canceled more. Of course we could have. The 2 goes into 6, goes in 3 times, and then you would have had 3 times 5. It's 15. So you can keep canceling if you can. Okay, so when you go to high school and you have your locker combination, it's actually not a locker combination. It's actually a permutation, because in your combination, order matters. Order does matter. Let's say your combination was 1, 5, 10, whatever the case may be. That's all you can use. If you use 10, 5, 1, it's not the same thing. 10, 5, 1 is not the same thing. So this is a permutation because order does matter. Okay, so again, with permutations, order matters. So in the next video, we'll talk about solving permutations.